velocity versus time graph, right? So since the velocity versus time graph has a zero slope, acceleration must be zero. By definition, acceleration is the change in velocity with time. If it's not changing with time, acceleration is zero, right? So B is the, D is the answer for that one. All right, H, what does the acceleration versus time graph look like for this one? Someone else, like Valerie.
The acceleration would originally start off as negative, and then it would switch to positive, so that would be G.
G, right. That's exactly right. We have a negative slope here. We have a negative constant slope, in fact. So we have a negative constant acceleration. We have a positive slope here, constant. So we have a constant positive acceleration. That's G. All right, so next one. Objects moving to the left, increasing speed. What does to the left mean, Adam? Negative. Increasing speed. Right, it's going farther down. It's right that the number is getting bigger, right? The magnitude is getting bigger. Right. That's the tricky thing, right? Right, it's increasing. It is increasing, but if we know that velocity is only, if you've taken into account the direction with the plus and minus, minus means nothing. It's not the same as a number line, right? It's the absolute value that's important. So, yes, you're absolutely right. So which one should it be? D, that's correct. All right. Now, Derek, what about the acceleration for this one? If D is the graph for velocity, what does the acceleration look like? Yeah, and why did you choose C? Yeah. Another better way of talking about that would be, how do we get acceleration from a velocity versus time graph? Yeah.
Well, you get it from the change in the slope. Since the slope stays constant, then the acceleration time graph would be a straight line.
Yes, but what can you tell me about the slope of D? Yeah. It's a negative slope, right, Derek? You look at it, you say it's a negative slope, constant velocity. So it's got to be a negative constant acceleration, right? So which one? You chose C, right? Okay. To the right, decreasing speed, stops, then moves to the left, increasing speed. Mike, you want to walk us through that one?
So it's moving in the positive direction,
right?
But slowing down.
Okay, positive, slowing,
And then it stops.
which means
Velocity of 0.
v equals 0. So what will that look like on a graph?
At x equals 0.
Yeah, so the velocity will at some point touch the time axis, right? Right.
and increases.
In speed. Right, which means
It accelerates.
it accelerates, right. So the magnitude of the velocity is getting bigger. All right, so which one of those reflects that story? A does, right. Exactly. So we've got a positive velocity, which is decreasing to 0. Then it stops, and then it's increasing. So this graph should look like ILE 12. Does it look like ILE 12? Remember where you push the cart up? Looks just like that, doesn't it? So whenever you're looking at these things, try to think not just in terms of the words, but also in terms of your experience, what you've seen, right? Think of that cart moving up and back because it's got a constant force acting on it, right? The fan going against the direction of its motion. So in this particular case, we're looking at A, and who can tell me, maybe Ali, can you tell me what does the acceleration graph look like for A?
It would be C, because it's the slope of the velocity time graph is negative. It's like a constant negative number.
Yeah, exactly. That's exactly right. It's C, because it's a straight line, it's constant, but it's a negative slope. So the answer is going to be C. All right. Next one. The object's moving to the left, decreasing speed. Who wants to walk through that one with me? Derek, did I already call on you to do one of these? Or did I ask you, Tim, to do one?
I think I did one a while ago, right?
All right.
Alright, so with this one, it's moving to the left, so that's in the negative direction.
Yeah.
And since the decreasing speed, would that mean because it's negative velocity be approaching the t-axis?
Yeah. Yeah. It's going towards 0. V, right? That's what it's doing. It's going towards 0V. All right, so which one of those graphs, velocity graphs, corresponds to that story?
Graph F.
Yeah, graph F. Starts off high, going in the negative direction, and heads towards 0. Right. That's graph F. Okay, and Derek, could you tell me what the acceleration time graph looks like for that? Yeah, why? Constant slope. Right, constant positive slope. So it has to be a constant positive acceleration. So it's B. All right, next one. Objects moving to the left with a net force acting to the left. So, Ali, will you walk me through this one?
Okay, so moving to the left, so it's negative.
Negative velocity, yeah.
And there's a net force acting to the left, then that would just make it more negative.
Right, more negative.
So that would be graph D.
That would be graph D. Yes, that would be graph D. And who wants to tell me what the acceleration, Adam, how about you tell me what the acceleration graph looks like? Because? Right. And we've done it. So let me